All right, ladies and germs, we're going to take a second take of my railroads video. I screwed up something before and it completely corrupted. So that being said, we're going to do it on the screen. Hope everybody's all caught up with your notes. You didn't have any reading guides for yesterday. Let's get into what we're doing today. So the first question for your warm-up on May 13th is, if you had to take a guess as to how fast the first steam locomotive went in miles per hour on average, how fast do you think it went? It gave you a few options. I think it was 2, 5, 8, 50. Can't remember all the choices, and I'm not going to go into it, but just give a guess. Remember, that's your attendance for the day, and we'll talk about it here in a bit. So we're going to have the video posted. We're going to have the reading guide, and then I think I'm going to do a YouTube video talking about the very first steam engine. Because we don't show a picture of it, and it is pretty interesting to see how archaic it looks. It is quite the contraption. So let's get into it. All right, so first steam engines that we see used, they're going to be in coal mines, right? And the idea of it is pretty sound, right? The idea that you have this source of energy that you use in the steam engines, and you can have it readily available to use. So what they're doing is they're digging down to get the coal out. Now, as you go farther down, they're close to the shore. So eventually what ends up happening is water starts flooding in. And this is not water that you're gonna take a glass and drink, ladies and gentlemen. This is dirty, polluted coal water. So they need to get it out of there in order to continue to dig. So what they do is they set up these steam engines outside, and they have a little well almost, and you have this arm pull the water up, and it's going to dump into a bucket. And of course, that needs to be emptied, which is probably not done very properly, but that is what it is. If you've ever seen an oil derrick, it does a very similar thing, right? It's pulling the oil up, and then it's getting put into a receptacle. You're just going to have to change it and then keep doing it. And because of that, they're able to mine a whole bunch of more coal in the same spot. It's so successful, they continue to do it. And in fact, these steam engines are now used so far and wide, they need to get coal from different places in order to continue to use them. Now, one of the coal workers, his name is Richard Trevithick. He's originally from Scotland, and then he ends up living in Britain and England, I guess technically. In 1803, he decides, hey, what if I take one of these steam engines, I put it on wheels, and then we have some sort of track for it to run? We can have this really powerful steam engine haul a whole bunch of coal really, really quickly. Well, he does definitely get a lot of coal to be hauled at once, and it's very successful. But there's two problems. One is that the machine breaks down all the time. It is incredibly inefficient. It's incredibly inefficient. And because of that, what ends up happening is we get a very, very low speed. Richard Trevithick's, when it was filled anyway, engine went about 2 miles an hour. 2 miles an hour. Not necessarily the fastest vehicle, right? But for the job that it's doing, as long as the coal gets there, that's fine. It doesn't need to be fast. It just needs to be something that takes the power off of humans having to haul such a heavy load so far. So in the beginning, that's enough. But then people say, look, this is an interesting invention. It's hauling something that's very heavy in a very long distance. But as an inventor, what can we do to improve on it? Well, I think the number one thing is that they make it faster, right? So what ends up happening is we have a few inventors trying to make steam engines or steam locomotives that are going to be faster than the Trevithick machine. And in order to do that, they need to be bigger, okay? And as a result, we get this beauty. This is called the rocket because it was supposed to go so fast. And the rocket, when it was empty and not pulling things, would clock out around 40 miles an hour. When it was towing things, it clocked in around 15 to 20 miles an hour. I know, some rocket, right? But it definitely allowed for people and freight to be transported faster and farther at a much better rate. Because 2 miles an hour, ladies and gentlemen, that's slower than we walk. Okay, so you're not going to really entice a whole bunch of people to get on a ride that goes 2 miles an hour. But 15, 20, ooh, now we're getting somewhere. Not to mention, you're in a car, for the most part, you're safe, and it can get you to the destination you want in a direct route. Now, the rocket becomes very, very popular, right? And there are other inventors saying, look, we have cities that are connected now, these factories that are using these steam engines before, now they have this new market or this new ability to sell things to a much farther place. What can we do to get in on this action? What can we do to make more money? Well, just take what Stephenson did with his rocket compared to Trevivik's machine, and then just expand on that. So eventually what we're going to get is these massive steam engines that are going to have more operating wheels. We have 2 here. We go to 4 now. You're going to have bigger boilers that are going to boil water way hotter on the inside. And then you're going to have better piston machines that push out straight and rotate better, as opposed to pushing up straight up and down, kind of an inefficient sort of way to push a wheel. Okay, so now we've got these machines that when they're full are going anywhere between 40 and 50 miles an hour. Now that's all fine and dandy, right? But there's one issue, is that each railroad company, and oh my gosh, were there a lot of them, each railroad company had the right to set the distance of its track and how far it is apart. It's called a gauge. And the smaller the company, the smaller the trains, used smaller gauges, right? Like this is a small rail car. You can see that the gauge, these are model trains, by the way, but it proves my point. The gauge is very close. As the cars get bigger, you notice that the gauge gets wider until eventually you get to these big companies that have the really wide tracks and the huge trains. There's only one problem, is that in a lot of cases, there's only one line of track going to one spot. And when you're in something like a train and they're in these cars, you can't just hook it up to the big train. What do you need to do? You need to unload the whole stinking car and then reload it onto another one. It got so ridiculous that in order to go from New York to Chicago on rail, whether you were freight or a passenger, it would take about 3 weeks. 3 weeks. Now, people were inventing bigger engines, but this guy, Cornelius Vanderbilt, says, look, how about rather than trying to improve on engine speed, why don't we try to improve on travel speed, destination speed, things that can get us there faster, and therefore it doesn't really matter how fast our engines go. All that matters is to get people from point A to point B quicker. And what he does is he takes this rail gauge and he standardizes it in his company. Now, he's able to do this because he is a filthy rich man, okay? That is why he is able to do it. And what ends up happening is that a trip that took 3 weeks from New York to Chicago on a standard rail system, a standard gauge, Cornelius Vanderbilt gets it to happen in under a day, 21 times faster. Ladies and gentlemen, you talk about a revolution, what a change. People are flocking to use rail system as a way to travel. Businessmen can go from major city to another and have business meetings so easily. Communication gets so much better. But the number one thing that's important, even more than passengers, is this freight starts to go from place to place so much faster. Now, for big companies, for people that are wealthy, they're going to reinvest their money and they're going to make bigger and bigger companies, because now they can sell, instead of just in New York, they could sell to New York, Chicago, Milwaukee, Detroit, all of these areas, right? So these big companies that can afford it, they're going to get bigger and bigger. The problem is that there were all these small companies that were in each individual town that they were able to sell things close to them because shipping was so expensive. It was so hard to get things that people only bought stuff that came in locally. Well, now these small businesses, because all these bigger ones are able to ship things for so much cheaper, they start going out of business. So just like with everything, we have people that are hugely successful. It makes business bigger. It gives people more jobs. But there are a lot of people that are smaller business owners that have to go out of business because of this. All right, ladies and gentlemen, make sure you get that exit ticket done. Your homework assignment is going to be the vocab 1 through 6. It's going to be due on Friday. Okay, ladies and gentlemen, I will talk to you later.